Alright, so we're going to look at the Level 2 Maths paper, which is the 2019 Algebra paper. And we're going to go over question 1. So I'll scroll down and we'll look at the first question, question 1a. And we are looking at solving the following two equations. So we're going to look at rearranging the first equation. So we're going to have 3x squared, and if I take the 7x across, it becomes minus 7 minus 6 equals 0. Just remember, we have to multiply the first number with the last number. So we're going to have 3 multiplied by negative 6, which equals negative 18. And then we're looking at two numbers that multiply to negative 18, but add to negative 7. Well, we can have negative 9 times 2. That equals negative 18, and negative 9 plus 2 equals negative 7. So I can rewrite this now as 3x squared minus 9x plus 2x minus 6 equals 0. Now we factorize in groups, so I'll factorize the first two terms. If I take 3x out as a common factor, I'm left with x minus 3. And if I take 2 out as a common factor, I'm left with x minus 3. And then if I take out x minus 3 as a factor, I'm left with 3x plus 2. Now, since we're told to solve this, we make each bracket equal to 0. So my solution will be x equals 3 or x equals negative 2 over 3. These are the two solutions. You could put this in your graphics calculator and just find the solution, but I thought I'll show you the working behind it as well. Next question, we've got 3 over x squared plus 4 over x equals 5. We want to solve this equation as well. So first things first, I'll take everything to the other side. So I'll have 0 equals 5 minus 3 over x squared minus 4 over x. Now I want to multiply them, have the common denominator. So what I'll do is I'll actually multiply 5 with x squared over x squared. I'll leave 3 over x squared as it is, and I'll multiply 4 over x with x over x. So I've got x squared as my common denominator. I'll come up here now. So I'll have 0 equals 5x squared over x squared minus 4x over x minus 3 over x squared, minus 3 over x squared. Obviously they don't have the same denominator, so all I'll have is, if I get rid of the x squared, if I multiply both sides by x squared, I'm just left with 5x squared minus 4x minus 3. Now what I could do is I can put this in my graphics calculator. So if I go down to equations, I should make this bigger a bit. There we go. Equation, polynomial, 2, I've got 5, negative 4, and negative 3. I get 1.271 or 1.272 and negative 0.472. I'll just round it to 2 dp, so I've got x is equal to 1.27 or negative 0.47, and these are my two answers. So these two questions up here are for achieved, so these are achieved questions. Alright, so if you get the answer correct, you got an achieved. So this will give you an A3 for the question if you get these two correct. Now moving on to question B. Question B, bit of a word problem. You can read through it. We've been given a function. We've been told that the initial cholesterol level is 9.18. So we know that the initial, that means K, because that's the initial value in T is 0, is 9.18. So our equation is C equals 0.02 T squared minus 0.6 T plus 9.18. Now I've been told how long it will take. I want to find out how long it will take for a person's cholesterol level to reduce to 5.05. So if I said C is equal to 5.05, which equals 0.02 t squared minus 0.6t plus 9.18. I want to make the equation equal to 0 because it is a quadratic. Minus 0.6t plus 9.18 minus 5.05. So again, I have 0.02t squared minus 0.6t, and this would become 4.13. Now again, I can just put this into my calculator over here. So I've got 0.02, negative 0.6, positive 4.13. I get 19.3 and 10.7. So I've got t is equal to 10.7, or t is equal to 19.3. Now, obviously they said over here that this function is only valid for the first 15 months. So therefore I can't, this is not my correct solution, because it's only, so therefore this is the only solution I have. And I can say that it will take $10.7 months to reduce to 5.05. Cool. So it will take 10.7 months to reduce to 5.05. So that's how we answer this question. This question will give you a merit. Right, so just I'll give you a merit. Oh, I forgot the 5 over there. 5.05. Cool. If you got the correct answer. Moving on to the next question. We've been given a polynomial and it can be written as a perfect square, so we're going to find the values of m. So if you had to find the values of m, we're going to use the discriminant. Oh, that's pretty bad. Discriminant, which remember is b squared minus 4ac. Okay, this is our a, that's our b, and that's our c. So I'll substitute that in. I've got m plus 1 squared minus 4 times 2m minus 1 multiplied by m minus 4. So if I simplify this, I've got m squared plus 2m plus 1 minus 4 bracket 2m squared minus m minus 8m plus 4. And then, so then if I simplify that, I'll get m squared plus 2m plus 1 minus 4 with 2m squared minus 9m plus 4 in brackets. I can simplify that further. Plus 1 minus 8m squared minus 36m minus 16. And then I can just add the like terms. So I will have negative 7m squared minus 34m. Oh, actually I did a mistake over here. That should be plus 36. Sorry. So that would become plus 38m minus 15. And again, what you could do is you can either put this in your calculator or you can factorize it. I'm going to put it in the calculator for now, because if I make it equal to 0, so I'll put negative 7, 38, negative 15, whoops, negative 15. I got 5 and 0.4285. So again, I'm just going to say discriminant equals 0, so therefore I've got m is equal to 5, or m is equal to 0.42, I believe. Just double check that. Yep, 0.43. 0.43. So now if we determine which one is the correct solution. Now if I put 0.43 for m, and if I especially look at the last value there, that gives me a negative number. If I get a negative number, it can't really be a perfect square. So I need a positive number to make it a perfect square. Because remember, if it's a negative number, it's a negative times a positive. If I want a positive times a positive, so then I can make it a perfect square. So therefore, m equals 5 is the only valid answer to make it a perfect square. So I'll have to write that down. So m equals 5 is the only valid answer for this to be a perfect square, because I want it to be positive. I want that C value to be positive. Next question, question D. So we got told by factorizing, find an expression for P for the difference between the roots of the equation. So first things first, I'll write my equation out. I've got px squared plus 4px minus 12 equals 0. I can rewrite that as p squared x squared plus 4px minus 12 equals 0. So now, because I've got p squared, I know that I'm going to have something along the lines of px, because px times px is p squared x squared. So now I'm looking for two numbers that multiply to negative 12 but add to positive 4. So I'm looking at a positive and a negative number. 6 times negative 2 adds to negative 12. And we know that 6 minus 2 equals 4. I'm not really worried about the p, because when I multiply it with the p's, it should get there. So if I go over here and write down plus 6 and minus 2, that is what I get. So now, if you want, you can expand this to check if it gives you this. Alright, but now I want to solve this. Remember, this equals 0. So we get px plus 6 equals 0, or px minus 2 equals 0. So over here we get x is equal to negative 6 over p, or x is equal to 2 over p. So I'm looking at the difference between 2. So if I just went 2 over p minus 6, or negative 6 over p, that becomes 2 over p plus 6 over p, which equals 8 over p. So that is my solution right there. So that's the difference between the two roots. I forgot to say that this question over here, if you stated the answer correctly and you disregarded the 0.43, that would have given you an excellence. This question over here as well, it will give you an excellence if you state the difference between the roots. This is the last question of question 1 in the 2019 exam. We're told to use algebra to show that the graph of the function where c is not equal to 0 crosses the x-axis at two distinct points. So we're looking for a discriminant greater than 0. So we're looking for the discriminant greater than 0. So first things first, I'll expand it out. So I've got x minus a, x minus b, minus c squared. I'll come across here, so y equals x squared minus bx minus ax plus ab minus c squared. So I can now obviously look at the common factors. So I've got y equals x squared minus a plus b x plus ab minus c squared. Now what I have over here is, this is my a, this is my b, and this is my c. So if I put up my discriminant, so remember discriminant is b squared minus 4ac, and I want my discriminant to be greater than 0. Discriminant formula now. What I'll do is I'll multiply this negative inside. So I'll have negative a minus b squared minus 4 times 1 times ab minus c squared. And I want this to be greater than 0. Let's expand it out. So a, or negative a minus b, negative a minus b, minus 4ab plus 4c squared is greater than 0. So we've got negative a times negative a is positive a squared, negative a times b is positive a times b, negative b times negative a is positive a times b, and negative b times negative b is positive b squared, minus 4ab plus 4c squared is greater than 0. Now we can go a squared plus 2ab. We've got minus 4ab over here, so I'll put it, slot it in there, plus b squared plus 4c squared. So I've got a squared minus 2ab plus b squared plus 4c squared is greater than 0. Now what I could do is I can actually factorize this part over here, just to simplify it a bit more. So I'll come down the bottom. Now I'm looking at two variables that multiply to b squared. Well, we know that what that is. B times b equals b squared. But we can also have negative b times negative b equals b squared as well. But I want them to add up to negative 2b. Well, therefore, if I want them to add up to negative 2b, then I'd probably want the negative b times negative b, because that will help me add it up to negative 2b. Alright? So b, so that means negative b minus b equals negative 2b. So I can actually factorize this as a minus b squared. And if you go over here, I'll write it down. If you go a minus b and a minus b and you expand this out, you should get a squared minus 2ab plus b squared, which is what we had originally. Alright? Then I've got plus 4c squared is greater than 0. So I want to have two distinct roots. That's why I want it to be greater than 0. So if I look at a and b, I mean a and b, they could be any number, right? If a was 0, b was 0, we'll just have 0 over there. Now we were told that c cannot be 0. C can be any number but 0. So c can be a negative number, c can be a positive number. So c can be any number but not 0. However, if c is a negative number or a positive number, c squared will always be a positive number. No matter what. It will always be positive. So therefore, I'm not really worried about a and b, because since I'm adding that, because again, that will always be positive no matter what the value is, even if it's a negative number. If b was greater than a, that will always be positive, and c would always be positive. Because I'm adding it, therefore this would always be greater than 0. So I have shown that this could be possible as long as you can state that c squared will always be positive. Alright, therefore it will give us two distinct roots. So therefore this will give us two, give us two distinct roots. Right, so that's how we solve this. Cool.